You can see the objectives of this video on your screen. At the end of this video, you will be able to describe hardware features of HANA, software features of HANA, and you will be able to explain what is in-memory database. So before going to hardware features, the first question you need to understand is why you need to learn hardware features of HANA. And the answer is HANA is so faster, or HANA can give you better performance because of a combination of hardware feature and software features. So HANA is different from other databases, or HANA can give you better performance compared to other databases because of its unique hardware and software features. So it's not just because of hardware features or just because of software features, but it's a combination of hardware features and software features. And that is why you need to understand what are the hardware features of HANA. So the first feature is HANA has multi-core architecture for CPU. What do you mean by multi-core architecture? Here you can see in the figure a CPU is shown with multiple blades. What is the purpose of this? Each blade of the CPU can work simultaneously and independently, and which will help you to achieve massive parallel processing. So this is one of the important hardware feature of HANA, why HANA can give you faster processing speed. The databases which were built prior to HANA, they were using CPUs with single core. And in HANA, you can see multi-core architecture, CPUs with multiple blades, and that is why you can see you can achieve massive parallel processing, that is MPP with HANA, and that is why you can get better performance with HANA. Another important reason is, or another hardware feature is, you can see 2 TB or 4 TB 64-bit huge memory or huge RAM. So now you can imagine if you have a 2 TB or 4 TB huge RAM, how much faster your system will be. So this is another important hardware feature of HANA. And as a result, you can expect minimum 100 GB data throughput using HANA system. And this will help you to reduce your price, because if you remember, you have learned in the first video of introduction to HANA that you can run multiple different systems on one single database. You can run multiple different applications on one single database. So instead of having multiple systems in your landscape, now you can just have HANA and you can plug in different applications on HANA system and start working on it. So this will help you to reduce the cost of your business. Now coming to software features, one of the important software feature of HANA is you can store the data in row store as well as in column store fashion. You can have data compression, or the data can be compressed at the backend while storing the data. You can have data partition. Aggregate tables are not required in case of HANA. And there is a concept of insert only on data for HANA. Now you will see these concepts one by one. So if you talk about row and column store table, how a row store table will look like and how a column store table will look like. So you can see on left hand side over here, you need to store this data. The first row is 1 Anushri TL, second row is 2 Neeraj AM, third row is 3 Priya SM. If you want to store this data in row store, you can see how it will look like. The below one and the upper one, you can see 3 columns. First column is 1 2 3, second column is name, third column is their designation. So this way you will be able to store the data in row store as well as in column store. Row store data you are already familiar with, because in ECC mostly it is row store. Or in other fashion, if I want to display the same data, how it can be stored in row store or column store, you can see first row is 1 Anushri TL, second row is number 2 Neeraj AM, so on and so forth. If it is a column store data, it will be first column as 1 2 3, second column with names, and third column with all the designations. So that means you have a choice in HANA whether to create your table as a row store table or as a column store table. Does that mean that I have a choice to decide whether VBAK table should be a row store table or column store table? No. I am not talking about standard tables. SAP has already taken care of standard tables. They have already converted their standard tables into either row store or column store tables depending upon usage. We have a choice for custom tables. So if I am going to create my custom table, I have a choice whether to create it as a row store or as a column store. Fine. But then how can I decide whether to go for row store or column store? Do I have a certain criteria or it depends on my liking? Obviously, SAP has come up with certain criterias, and here are those criterias. If you want to create a row store table, what is the criteria? If you want to handle insert, update or delete functionalities, or in other words, if you want to use your table for transactional operations, that means storing the transactional data, or for OLTP operations, then you can use your table or you can create your table as a row-based table. What happens in case of row-based tables? Or what happens when you are using the table for transactional purpose? In that case, you are using maximum columns of your table. So that is why it's better to create it as a row store table. When to create it as a column store table? If you want to use your table for select operations or aggregations, or I can say for analytical operations, that is OLAP, then you can create your table as a column based table. So the ground rule is, if you want to use your table for storing the transactional data, that means for OLTP purpose, you create it as a row store table. And if you want to use your table for aggregations, that is for OLAP purpose, you create it as a column store table. Or in other words, I can also say that if you want to use maximum columns or maximum fields of your table frequently, then you create it as a row store table. And if you want to use selected or limited fields of a table frequently, then you create it as a column store table, because when you do the aggregations or analytics, you are using limited fields of a table frequently. So this is a ground rule that for OLTP purpose, you use a row store table. For OLAP purpose, you use a column store table. But what if I want to use a table for both the purpose? In that case, SAP recommends to go for column store table. In general, SAP says that even though you have a feature available for creating the table as a row store table or column store table, SAP recommends that whenever possible, you create your table as a column store table. Why so? Because if you create a column store table, you will get a better performance compared to row store table. Why you will get better performance with column store table? The first reason is, when you create a table with a column store table, the data will get compressed at the back end. As a result, you will be able to save the memory space. And second important reason is, you will be also able to achieve massive parallel processing with column store table. So how it will? For example, if you want to store this column store table in HANA system, this table has 4 columns: first name, last name, department and salary. Under first name, you have values like Rohit, Anushka, again Rohit, Isha and Ravi, and different values in last name, department and salary columns. The system will run certain compression algorithms at the backend automatically, and it will compress the data at the backend automatically. For example, you can see over here a dictionary compression algorithms is executed. In this case, it will create indexes for these values. So if you see the first column for first name under dictionary compression, value Rohit has index 0, value Anushka has index 1, value Isha has index number 2, and value Ravi has index number 3. So you can see, instead of storing the names as Rohit, Anushka and all those, the system is storing only index number at the back end. What is the use of this? One usage is obviously you are able to save the memory space. So instead of storing long words, you can just store index numbers. This will help you to save the memory space. And another usage of this is you will be able to fetch the data very quickly. For example, if you are using any book, you have an index for your book. And if you want to search for a particular page, if you want to go to a particular chapter, then you refer to your index which is given at the beginning, and you can search for a particular page or chapter very quickly. So the same concept is applied over here in dictionary compression. Another compression algorithm you can see over here is a run length compression. So what happens in this case is, this is a further compression which happens on top of dictionary compression. So in this case, you can see first column how it is stored. First value is Rohit, which has index 0. So it will say 0 is appearing for one time. So 0 into 1. 0 is appearing for one time. So you can see double quotes for 0. So that is the index number. So 0 is appearing for one time. Second value is Anushka, which has index 1. So it will say 1 is appearing for one time. 1 which is noted into double quotes, that is an index number. The next value is again Rohit, which has index 0, which is appearing for one time. So it will again say 0 is appearing for one time. The next value is Isha, which has index number 2. So it is saying 2 is appearing for one time. The next value is Ravi, which has index number 3, which is appearing for two times. So one time. So it is showing 3 is appearing for one time. Now you can check the second column in which you have last name as Sharma, Gupta and Verma. Index number for Sharma is 0, index number for Gupta is 1, index number for Verma is 2. So since Sharma is appearing continuously for two times, which has index 0, it will say 0 is appearing for two times. Then again next value is Gupta, which is appearing continuously for two times, which has index number 1. So it will say 1 is again appearing for two times. The next value is Verma, which has index number 2. However, it is appearing only for one time, and that is why it is saying 2 is appearing for one time. Or if you see the third column, LKM and HR, the department, LKM value has index number 0, which is appearing for 3 times. So it will say 0 is appearing for 3 times. The next value HR is appearing for 2 times. It has index 1. So it is showing 1 is appearing for 2 times. So like this, different compression algorithms are executed at the back end automatically, and the system compresses the data while storing it actually in the database. However, please note that the compression algorithms are not limited to whatever you can see on the screen. There are multiple such compression algorithms, and system picks up which algorithm, or system decides which algorithm to execute for which table. So this is the first reason why SAP recommends to use column store table instead of row store table. The second important reason is, when you create a column store table, say suppose you have 2 columns in your column store table, then each column of your table will be picked up by each blade of the CPU. So if you have 2 columns, 2 blades of the CPU will pick up or process 2 different columns of your table simultaneously and independently. Because in HANA you have learned that the CPU has multi-core architecture. That means the CPU has multiple blades. If you have multiple columns in your column, multiple blades of the CPU or each blade of the CPU will pick up each column of the table, and each blade of the CPU will work on each column simultaneously and independently, which will help you to achieve massive parallel processing. So this is another important reason why SAP says that instead of row store table, you go for column store table. So this is what you can see, that the first reason why column store table is preferable is the data gets compressed at the back end. The second reason is because of multi-core architecture of HANA, or the multi-core architecture of the CPU. Each blade of the CPU will pick up each column of the data and it will work simultaneously and independently, through which you can achieve massive parallel processing. So now you can understand that why HANA is so faster. It is because of a combination of, or maybe you can say a right combination of hardware and software features. So because of this, you can get better performance on top of HANA. The next software feature of HANA is there are no aggregate tables in HANA. So before HANA, that means in ECC, there are multiple aggregate tables that are used. What is the purpose of aggregate tables? What is aggregate table? Say for example, consider finance module. In finance module, the users are always interested in getting reports for open invoices or closed invoices. So if the user want to get a report for open invoices for a particular quarter, then what the system has to do is, the system has to pick up the data from underlying database tables like BKPF and BSEC for that particular quarter, then do the calculation of debits and credits. If the debit and credit is matching, that means if the sum is 0, that means the invoice is closed. If the debit and credit is not matching, that means the invoice is open. Show that report on the screen. But in reality, for finance module, you have huge number of data, and as a result, it is very difficult to pick up the data and do the calculations at runtime and show the report. Because the database doesn't have that capacity to handle huge amount of data and do the calculations at runtime, SAP has come up with the concept of aggregate tables in case of ECC. So what happens is, when you create an invoice in the system, at that time itself, the system immediately calculates whether this invoice is open or closed. If the invoice is open, it is stored in a particular aggregate table. And when the user asks for open invoices reports, the data is picked up from that aggregate table instead of hitting BKPF and BSEC, and you can see the report on the screen. So all this is done because the underlying database has limited capabilities. And the issue with maintaining aggregate tables is sometimes that you don't get up-to-date data in these aggregate tables. So what is the solution? In case of HANA, SAP says that you don't need any aggregate tables. Why so? Because you have learned that HANA has the capacity to work on huge number of data at a very huge amount of data at a very high speed. So what HANA can do is, if you ask for any open invoice report on top of HANA, the system can pick up the data from underlying database tables. The system can do the calculations at runtime and display the report on the screen. HANA has that capacity to do these calculations at runtime. This is called as on-the-fly aggregation. So HANA has the capacity to do the calculations on the fly, and display the report on the screen. And that is why you do not need any aggregate tables in HANA. Obviously, as a result, the number of tables is reduced in case of HANA. You will discuss this point in one of the next video also. The next feature of HANA is insert only on delta. In order to understand this feature, you need to first understand what is in-memory database. I hope you remember you have learned that HANA is an in-memory database. What do you mean by in-memory database? Let me draw a picture of HANA database over here. So here I am showing two parts of HANA database. One is a persistent layer, the lower part, and the upper part is a RAM. And together is HANA database. So what is persistent layer? Persistent layer is a permanent memory wherein all your database tables and the values are stored permanently into the database. And obviously you know RAM, it is a volatile memory. If the connection goes off, whatever data you have in RAM, you will lose that data. So in case of HANA, all your data, all your tables are permanently stored in persistent layer. Suppose a user starts working on HANA database and the user is trying to fetch the data for a particular sales order from HANA database. That means the user is trying to fetch the data from VBAP table and the user is trying to fetch the data for a particular sales order frequently. So HANA system is quite smart. When the user starts working on HANA system, the system starts analyzing which type of data this user is accessing frequently. So the system identifies frequently used data by the user. Now in this case, this user is accessing sales order data frequently from VBAP table. So then next time the system loads this frequently used data into RAM. So that if the user asks for the same data, next time the data will be picked up from RAM instead of hitting persistent layer. And then the user will get better speed because the user is picking up the data from directly RAM. And if you remember, you have also learned that in case of HANA, there is a huge RAM, 2 TB or 4 TB RAM which is available in HANA. So obviously there is a huge space in RAM. RAM is very faster. So if the system loads frequently used data into RAM and as a result the user starts getting better speed with HANA. Obviously all these things happen at the back end. The user don't get any idea what is happening at the back end. But the idea is whenever any user starts working on HANA system, the system analyzes which data user is accessing frequently and that frequently used data gets loaded into RAM, and next time when the user asks for the same data, the data is picked up from the RAM instead of persistent layer. This concept is called as in-memory database. Now when you are working on HANA system, SAP has also come up with a concept of data temperature, different temperatures of data. Obviously not physically but logically. So there are 3 different temperatures of data, or you can say that SAP handles data in 3 different temperatures concept. The first temperature is hot data, that is the frequently used data which is loaded into RAM. The remaining data which lies in the persistent layer is treated as warm data. And obviously now you can imagine the third temperature is cold data, that is your historical data or archived data which you might have archived and stored it in some other device also, maybe a disk or any other backup device. So that is a cold data. So that means depending upon the usage of data, SAP handles the data in 3 different temperatures: hot data, warm data and cold data. So that means with in-memory database, the data storage and processing happens within the memory, and using in-memory database helps us to increase the speed, and data is handled according to the usage, or the data temperatures are created according to the usage of the data. Up to this point this is fine. However, suppose a user has started working on a particular sales order and that sales order data is treated as a frequently used data or a hot data, and this hot data has been loaded into RAM, and now the user has started changing the data, changing the hot data. That means user has started changing that sales order data. The user may change the data, user may delete the data, user may add the data. So what will happen in that case? Where the change will be recorded? Where the change will happen? Will it happen in RAM or whether it should happen in persistent layer? Now the hot data is already there in the RAM. So obviously the change has to happen in RAM. But then if you do the changes in RAM and if your connection goes off, then whatever changes are done will be lost. Yes. So what is the solution? So what SAP does is, if the user starts changing or deleting or adding records in hot data, the changes are done directly in RAM. However, at the same time, the changes are also recorded in a log file, which is a part of persistent layer. So whatever changes user is doing in hot data, the changes are getting done in RAM. However, at the same time, those are getting recorded in a log file, which is a persistent layer. So you are recording the changes in a log file, and after definite frequency or a definite interval, the persistent layer will read the log file and do the changes in actual database. So this frequency or this interval is called as a save point, and by default the setting for save point is 5 minutes. I will quickly revise what I am saying. We are talking about a user who is working on a sales order data. So that is a hot data which has got loaded into RAM, and now the user has started changing that data. Now I am saying that the change will happen in RAM. However, the change will also get recorded in the log file, which is a part of persistent layer. And then at a definite interval, the persistent layer will read the log file, and whatever changes are recorded in the log file will be actually done in the database, and then those will be again loaded into RAM. And the frequency at which the persistent layer reads the log file, that is called as a save point. By default, the setting for save point is 5 minutes, which you can change. The basis team can change this setting as per business requirement. So what is the use of this log file? When the user is doing the changes in hot data, at the same time those changes are getting recorded in a log file. So suppose in between the connection goes off, still you are safe because the changes have got recorded in log file. So if the connection goes off, the system will record the changes in the log file before the connection goes off, and when the connection resumes, the system or the persistent layer will first read the log file. Whatever changes are recorded in the log file will be done in the actual database tables. Again, the hot data will be loaded into RAM. So this is how SAP takes care that even though the user is doing the changes in the hot data in RAM, still you are safe. SAP is taking care that those changes are recorded into persistent layer. This concept is called as insert only on delta. Why it says insert only on delta? Because when you are inserting new records in your hot data, you are doing those changes, you are doing that insert operation in directly delta. Delta means RAM. RAM is treated as a delta over here. That means you are doing the insert in delta directly, and that is why this concept it is called as insert only on delta. I hope you have got this. If you need any more details around this, if you have any more questions, you can contact SMEs from LKM team. So all the best, and please continue your learning for the next videos of Introduction to HANA.